This is the same setup as our previous problem. If you haven't done that problem yet, you should do it before this one. The key difference is, in this problem, the concentration of the 2+ metal cation is different for each of the two metals. So we're going to have to solve for a specific oxalate concentration where these three different solutions are in equilibrium. To start, we'll just look at the barium oxalate. Barium oxalate, when it dissolves, will release barium 2+ and oxalate ions. Here's our KSP expression. We solve for the oxalate ion concentration. Now, when we get a numerical value for that, that corresponds to the concentration where this barium oxalate system is at equilibrium, i.e. we have a saturated solution. To actually precipitate the salt, the barium oxalate salt, the concentration of the oxalate will have to be a little bit higher. We've solved for this concentration. This is the concentration of the oxalate required where the solution is going to be saturated in the given oxalate. In this case, the KSP values and the concentration of the metal cations are both different for all three of these salts. That's why we have to solve for a numerical value for the oxalate concentration. All right, and here we've solved for those relevant oxalate ion concentrations. So the correct answer is strontium oxalate. It's going to require the lowest oxalate ion concentration for the ion product to exceed KSP and therefore cause precipitation.